Hi, boys and girls, and welcome back to Mr. Grable in our Grade 3 ELA class, where we read from collections. And today, we have a story from Super Senses collections, called Sounds Like Fun. Sounds, one of the five senses. Sound, sight, smelling, feeling, tasting. Yeah, tasting. Oh. Yeah, tasting. Candy canes. I know, it's not even December anymore, but candy canes are still good. Yeah, bouncy balls. Maybe not the bouncy balls. Sounds like fun though. Oh, it looks like to me we're gonna hear a whole bunch of different sounds. Oh, I might have to create some sounds. When you're reading, not a bad idea. Use different voices, use sounds. Makes it more interesting for the listener and for yourself. Sounds like fun. Caw, caw, caw. Yip, 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 yip. Oh, I see that just right at the front there. Right in the front. All the animals making no noises. By Barbara Shapiro, illustrated by Pat Couples. A bee buzzes, a dog barks. Leaves rustle in the wind. Sounds are all around us. Have you ever wondered how these sounds are made? Sounds like science. They're caused by vibrations. Gently touch the front of your throat. Say something out loud. I can feel that. Do you feel your vocal cords moving? I do. Your vibrating vocal cords produce sound waves that travel through the air and into your ears. Wow. Amazing. What are sound waves? I wonder, on that second page there, what are they? Well, when you walk or run, the air moves around you. You push the air in front of you. And behind you, air moves in to fill the space your body just left. The same thing happens when your vocal cords vibrate. They act just like a rubber band stretched between your fingers. When you pluck the center of the rubber band, it moves back and forth, pushing the air around it. The air is made up of tiny particles called molecules. As the molecules of air that are next to the rubber band move, they push other molecules of air. You can see the rubber band moving, but you don't notice the air moving because it is invisible. Don't see the air, do you? Nope. To see how air moves near a vibrating object, put about 3 centimeters of water into a large bowl or pan. Ooh, this would be like a science experiment. Then drop a penny in the center, or any coin. Do you see waves of water moving away in all directions? These waves are similar to waves made in the air whenever something moves. You just can't see it in the air, but you see it in the water. Each wave pushes the air molecules that are near it, and another wave is formed. Sound is carried on waves of vibrating molecules. These waves are called sound waves. The waves of water around the penny start out strong. They get weaker as they move away. The same thing happens to sound waves as they move farther away from a plucked rubber band or another moving object. This is why a sound is louder when you are closer. to where it comes from. It's also why it can't be heard at all when you are too far away. If I went, really, really far. How do we hear sound waves? Well, sound waves move through the air. As they enter our ears, they push on our eardrums, sending signals to the brain where the movement is translated into sound. To see how this works, you'll need a cardboard tube from paper towels or toilet tissue. A balloon. Ooh, this looks like an experiment I'd like to do. A rubber band. And a pencil. There they are. Oh. Check this one out. Now, ask an adult for a candle and a match. Make sure you ask an adult for that one. That could be dangerous. Cut a piece of rubber from the balloon and stretch it across one end of the cardboard tube. Oh, I see it there. Attach it with the rubber band. Oh, the rubber band. Then place the other end of the tube, the end without the balloon, the empty kind of end, about 3 centimeters again, not 1, not 2, about 3 centimeters away from the candle wick. Ooh, pretty close to it, but not right up to it. You may need to rest the tube on a book to get it to the right height. Light the candle, only with an adult there. Then turn off the lights and tap the stretched balloon sharply with the eraser end of the pencil. Does the candle flame move? When the balloon is tapped, it moves back and forth very quickly. This movement makes air waves inside the tube, which begin at the balloon and move through the tube and past the candle flame. These moving waves of air cause the flame to flicker. Not quite go out, but flicker. Oh, ooh, some good labeling there on the diagram. Oh, here's another caption up here labeling eardrum. There's your eardrum. Shows the sound waves. Since the human eardrum is much more sensitive than a rubber balloon, moving air molecules are enough to make it vibrate. Rather than sending the sound waves through an empty cardboard tube, the ear sends them through a series of bones and tissues and liquids. And inside, instead of sending them to a candle flame, our ears send messages from the sound waves to our brains. Powerful stuff. How do we hear different sounds? When moving waves of air enter our ears, we hear a sound. The sound's pitch depends on how fast the molecules of air are moving. Fast-moving sound waves make high-pitched noise, like a whistle or a mosquito's buzz. Slower-moving waves make lower-pitched sounds, like the beat of a big drum. Boom, boom, boom. Sometimes air molecules move too slowly or too quickly, and we can't hear them at all. The airwaves made by the flap of a butterfly's wings are too slow to be heard by human ears. Never knew that. Some sounds, such as the cries of bats, move the air waves very quickly, making them too high-pitched for us to hear. Bats can hear them though. Other animals, such as dogs, are also able to hear higher pitched sounds than we can. That is one reason many hunters use dogs to help them find their prey. supersonic hearing on some of those dogs, probably. What have you learned about sound? Oh, they're going to tell you, tell you what they told you and then tell you and then tell you. Good writers. Think again about that bee. That bee. How does it make its buzz? What part of the bee is moving? Think about the dog. Why do some dogs have high-pitched barks and others have low-pitched barks? Do their vocal cords move at different speeds? And what about those rustling leaves? Why can you only hear them if you're close by? Does it have anything to do with the distance the sound waves are able to travel through the air? Listen carefully to the world around you, and you'll discover the answers. That's pretty loud. Ooh, that's a high pitch. That bell. Dog going, woof! Meow. Mew, mew, mew. Croak, croak. Cheep, cheep, chirp. Oh, making animal noises is kind of fun. That bell was just kind of crazy. There's sounds everywhere. I'm gonna sound off now. Sound off. Bye-bye. Have a good day.